by 2। यही हमने प्रूफ करना था कि रेजिस्टेंस इज मैक्सिमम व्हेन R1 and R2 are equal। Now the next one is a beam of length L is supported at one end. If W is the uniform load per unit length, the bending moment M at distance x from the end is 1 by 2 Lx minus half Wx square. Find the point on the beam at which the bending moment has a maximum value. So, differentiate this with respect to x. dm upon dx. Derivative of x is 1. Derivative of x square is 2x. Put first derivative equal to 0. L by 2 minus Wx is equals to 0. From here x is equals to L upon 2W. Now find second derivative, d square m upon dx square. Constant W derivative of x is 1 minus W, that is less than 0. If we find the second derivative at x is equals to L upon 2W, then also it is less than 0. Therefore, x L upon 2W is point of maxima. Or what do we want to prove? We have to find the point at which it is maximum. So at x is equals to L upon 2W, the point is at maximum distance. So M is maximum when x is equals to this. Clear? Now the next one, show that all rectangles with given perimeter the square has largest area. We have given rectangle with a given perimeter. We have to show that square has the largest area. Let x and y be length and breadth of rectangle. What is the formula for the perimeter of rectangle? Perimeter of rectangle is 2 times L plus B. That is 2 times x plus y, and area of rectangle is length into breadth. That is xy. Clear? Now from here, P minus 2x upon 2 is equals to y. P by 2 minus x. Put this value of y in area. X, P by 2 minus x. P by 2x minus x square. Differentiate with respect to x. We get this. Now put the first derivative equals to 0. So we get x as P by 4. Now second derivative, minus 2, that is less than 0. Therefore, x is equals to p by 4 is point of maxima, and we have to show that the square has largest area. From here we get p as 4x, and let this equation as 1 and this as 2. Put the value of p in equation 1. So we get 4x is equals to 2x plus 2y. So it implies 2x is equals to 2y. That is x is equals to y. If length and breadth both are equal, it means all sides of rectangle are equal. Then it makes a square, because square has all sides equal. Therefore, write down A is maximum. Therefore, A is maximum when x is equals to y. Therefore, rectangle is a square. Therefore, rectangle is a square. Now the next one. Show that all rectangles of given area, the square has smallest perimeter. All rectangles of given area, square has smallest perimeter. This is what we want to prove, कि square has smallest perimeter. Write down. Rectangle is given, so let x and y be length and breadth of rectangle. Now, area of rectangle, length into breadth. Perimeter of rectangle, 2 times length plus breadth. From here, find the value of y, because we want to prove the area is, perimeter is smallest. So we have to differentiate the perimeter. Now put the value of y. Differentiate with respect to x. Derivative of 1 upon x is minus 1 upon x square. यही होता है हमारे पास. So we can take 2 common, 1 minus a upon x square. Put first derivative equal to 0. So what we get? 2 times 1 minus a upon x square 0. X square minus a upon x square 0. So x square minus a. What is the value of a? A is xy. Use 1 here. Let this equation as 1. So we get x is equals to y. Find the second derivative. Derivative of 2, 0 minus 2a constant. X power minus 2 upon x cube. So we get second derivative 4a upon x cube. A is xy. So 4y upon x square. And we have x is equals to y. So second derivative is greater than 0 when x is equals to y. Therefore, x is equals to y is point of minima. और अगर x और y इक्वल हो गए, then perimeter की हमारे पास क्या वैल्यू आई? 2 into into 2, 4x. And what is the perimeter of square? 4 into side. अगर x और y equal हो गए, it means rectangle is a square. Since x is equals to y, therefore rectangle is a square. And therefore perimeter is minimum when x is equals to y. So this is the perimeter of square, 4 into side. Therefore perimeter is minimum when x is equals to y. Note it down. Next one. Show that all the rectangles inscribed in a circle. Show that all the rectangles inscribed in a circle the square has maximum area. The square has maximum area. Write down. Let ABCD be a rectangle inscribed in a circle with center O. Let ABCD be a rectangle inscribed in circle with center O. Let AB is equals to 2x. BC is equals to 2y. Length and breadth of rectangle and circle has radius A. AB is length of rectangle, BC is breadth of rectangle, and the circle has radius A. So this is the center of the circle. So this is the radius A. Now in triangle AOM, use Pythagoras theorem. So hypotenuse square is equals to perpendicular square plus base square. A is square root of x square plus y square. Or from here we can find y as square root of a square minus x square. Now area of rectangle, length into breadth, 4xy. Y is square root of a square minus x square. Now differentiate with respect to x. U into V rule. First function, derivative of square root of x is 1 upon 2 square root of x. Derivative of a square 0 minus x square minus 2x plus a square minus x square. Derivative of x is 1. So what we get? Minus x square. Take the LCM. A square minus x square. Square root will get cancelled here. We get this term 4 into a square minus 2x square upon square root of a square minus x square. Now in the next step, put first derivative equal to 0. So we get a square minus 2x square is equals to 0. A square is equals to 2x square. Or x square is equals to a square by 2, or we can say that x is a upon square root of 2.